So this is density. Start with a definition of density. Density is the measure of mass per unit volume. Okay, meaning it's how much mass is in a certain amount of volume. Okay, density equals m over v, where m is mass and v is volume. Okay, typically mass is going to be a solid and your volume is going to be a liquid. Okay, units, typical units that accompany density, you've got grams per milliliter, kilograms per liter, gram per cubic centimeter. Okay, one thing that you need to know, right, is that 1 milliliter is equal to 1 cubic centimeter. Okay, so 1 milliliter is equal to 1 cubic centimeter. So these two are essentially identical units. The only difference being cubic centimeters probably more likely to be used with some sort of solid object as opposed to milliliters, which would be used as a in a liquid. Okay. Density of water. Of water is 1.0 grams per milliliter. Okay. So if a density equals something that is greater than 1.0, that means it will sink in water. Okay. If density is less than 1.0, that means it will float in water. Okay. So let's look at a couple of examples calculating density, calculating different parts of the density formula. Example, let's say a rock has a mass of 127 grams and displaces 32.1 milliliters of H2O. Okay, what's the density? And when I say displaces, that means it moves that water out of the way. Okay, so a water displacement is a good way to find the volume of an odd object. Okay, so before we get into the actual example, let's explain what water displacement is. Okay, so if you have a graduated cylinder, okay, and let's say that its volume is at 10, okay, with nothing in it, you're going to put your little rock into there, okay, and the water's going to rise because that's what happens when you put solid objects in water. The water level raises. So let's say this was 10 and now it's up to 12 with our little rock at the bottom. Okay, so you have 10 milliliters without the rock, 12 milliliters with the rock. So that means your rock has a 2 milliliter volume. Okay, that's water displacement. This rock in this example displaces 2 milliliters of water, so its volume is 2 milliliters. Okay, so let's get back to our example. Density equals mass divided by volume. If you have never seen the density triangle, here it is. Okay, density equals mass over volume. And the way you work this density triangle, it tells you every equation you need to know as far as density goes. So if you're looking for density, you're going to cover up density, okay, and it's mass divided by volume, mass over volume, okay? if you're looking for mass, or sorry, if you're looking for volume, you're going to cover up volume. Uh-oh. You're going to cover up volume. Yeah. Let's try it again. You're going to cover up volume, and it's mass divided by density. Okay? Mass divided by density. And if you happen to be needing mass, you're going to cover up mass. I don't know why it keeps doing that. Mass. Okay? And it's density times volume. Okay? Density times volume. All right? So we need density, so it's mass divided by volume. So our mass is 127 grams. Our volume is 32.1 milliliters. 32.1 milliliters. So all we're going to do is divide that, and we end up with 3.9563. We use our significant figure rules when dividing. Okay, each one of these numbers has 3 significant figures, so our number has to have 3 significant figures. So we're going to count over 3 significant figures, which is the 5. We're going to look to the 6, and that tells us to round up. So 3.96 grams per milliliter is our answer. Okay. We're going to do 2 more examples. Okay. So a 1.00 deciliter sample of carbon tetrachloride. Okay, it really doesn't matter what you call this. It doesn't matter what this is. Okay, you could call it carbon tetrachloride. You could call it Sophia for all I care. It really doesn't make any difference what this thing is. Okay, so you have a 1 deciliter sample of something. Okay, and it has a mass of 1.58 kilograms. Okay, so find the density in grams per milliliter. Okay, so what do we have? We have deciliters and kilograms, and we want grams per milliliter. Okay, so we need to convert those. So 1.00 deciliters needs to be converted into liters, and 1.58 kilograms needs to be converted into grams. Okay, so 1 deciliter is equal to 100 milliliters is what we need to convert that into, not liters. 100 milliliters, okay, and 1.58 kilograms is going to be equal to 1,580 grams. Then we have density equals mass divided by volume. Mass is 1,580 divided by 100, okay, and your density equals 15.8 grams per milliliter. Okay, make sure you're paying attention to what the question is asking you for and what it is giving you. Okay, last one. All right, we have a cube with sides that each measure 2 centimeters. Okay, has a volume of, has a mass, messed that up, has a mass of 36 grams. Okay, so want the density. Grams per cubic centimeter. Okay, now our volume, all we're told is that we have a cube with sides that each measure 2 centimeters. So revert back to, I don't know, 7th or 8th grade math when you're learning about volume. Okay, and it's length times width times height. Okay, each of these is 2. Okay, so 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8. Okay, so volume equals 8 cubic centimeters. Okay, 8 cubic centimeters. Now, density equals mass divided by volume. We've just found our volume, okay, and we have our mass right there. So 36 divided by 8 is going to give you your answer. Okay, and when we do that math, we end up with 4.5 grams per cubic centimeter. Okay, sometimes you have to do a little bit of thinking. What do they give you? They tell you that something's got 2 centimeters on each side, so you have to use that information to find the volume. Okay, that is density.